In this class, I want us to look into this concept on the board, and that concept is equilibrium of forces. Equilibrium of forces. This is a topic in physics. Now, let us look at the concepts. We start with the concept of equilibrium. Resultant force, equilibrant force, moment of a force, couple, center of gravity, principle of moment. Then we'll look at a minor example. This is very important as WAEC SSE is ongoing now. Now, what do we mean? It is even important for the sake of practicals as well. Now, what do we mean by equilibrium of forces? The term equilibrium simply means being balanced. So we say that a body is said to be in equilibrium when there is no net force acting on the body. In other words, the body is not accelerating. That means the body is either at rest or is moving with a uniform speed in a straight line. Or the body, if rotating at all, is rotating with uniform angular velocity. Then such a body is said to be what? In a state of what? Equilibrium. Now the body can be in a static equilibrium or dynamic equilibrium. What do we mean by being in a static equilibrium? The body is said to be in a static equilibrium when the body is at rest, not rotating at all, or not moving at all in a straight line. Then when the body is moving in a straight line with uniform velocity, that means the body has no acceleration. Or when the body is rotating with constant angular velocity, in other words, the body also has no acceleration at that point. So that body is said to be what? In a dynamic equilibrium. Said to be in a state of dynamic equilibrium. That's good. Now let's look at resultant force. These are some concepts or terms that we come across when we are talking about equilibrium of what? Forces. Now, what do we mean by resultant force? From the term result, the resultant force is that single force which, when acting alone, we give the same effect in magnitude and duration as two or more forces acting together in a system. So that's the resultant force. That single force that when acting alone, we give the same effect in magnitude and direction as two or more other forces acting alone, acting upon a system. That is what? A resultant force. That is good. Then let's look at equilibrant force. Equilibrant force. These are not the same thing. By equilibrant force, we mean, that is from the word equilibrium, equilibrant, balancing. Equilibrant force is that single force which will balance other forces taken together, acting in a system. That's the equilibrant force. For instance, when we have a tripod, if you remove one leg of a tripod, it will no longer be at equilibrium. It will fall off. So at that point, it is no longer in equilibrium. So an equilibrant force is that single force which will balance other forces taken together, acting in a system. That's the equilibrant force. Then it has a relationship with the resultant force. Or what is the relationship between the equilibrant force and the resultant force? The equilibrant force in a system of forces have the same magnitude with the resultant force, but acts in opposite direction. So it is equal in magnitude with the resultant force, but opposite in direction with the resultant force. That's the relationship between equilibrant force and the resultant force. Take for instance, see the analysis. Assume I have a system of these are forces. Have here F1, F2, F3. These are forces acting at this point. So we can see that this F1 is equilibrant to this F2 and F3. Then F2 is equilibrant force to this F1 and F2 because it is balancing them like a tripod, for example. F3 is also equilibrant force to F1 and what? F2. It is balancing the other two forces. Then, if I should take here to be my resultant force, for instance, if here is my resultant force, let me call it FR. And if here is my resultant force, and this is the equilibrant force, let me call here now equilibrant force in this system. So I can see that the resultant force here is equal in magnitude, but opposite in direction to the equilibrant force. So equilibrant force is equal in magnitude, but opposite in direction. If the equilibrant force is acting northwest, then the resultant force will be acting southwest. If the equilibrant force is acting towards east direction, the resultant is acting towards what? West direction. That is how they're related. Thank you. Now let's continue. We have what we call moment of a force. Moment of a force. What do we mean by moment of a force? The moment of a force is the turning effect of a force about a point or an axis. The moment of a force is the turning effect of a force about a point or an axis. Remember, moment of a force is different from momentum. Momentum has to do with mass and velocity of a body. When there is impact, it has to do with, it's a different concept. So, in other words, you can say that analytically, that the moment of a force is equal to the product of a force and the perpendicular distance from its point of action. That is the moment of a force. So the product of the force and the perpendicular distance from its line of action from the point. That's the moment of a force. That is it. For instance, we can say that the moment of a force, if this is a force, this is a force acting, and this is a pivot, a body. From here to here is A. If here is a force, then the moment of a force about this point here, the moment of this force about this point is the product of this force and the perpendicular distance from this pivot, from this point of action. For instance, when you are turning a door, sliding a door, opening and closing a door, you are applying a perpendicular force to the door, and the pivot is the hinges. Then the moment of a force is the product of the force you apply to the door and the distance from that point to the hinges. So here, we can say that the moment here, moment about the point P here, the moment here should be equal to what? Force times what? Perpendicular distance. This is the perpendicular distance. So you can see that the unit of moment of a force should be what? Newton meter. That force times distance. That is moment of a force about a point or an axis. Now let's look at another concept, which is couple. What is a couple? By couple here, we don't mean married people. This is not about marriage. So by couple here, we mean system of forces. So a couple here means two, that is, the couple is constituted by two equal but oppositely directed forces that are not acting in a straight line. Two equal parallel forces that are oppositely directed but not acting in a straight line constitute or forms a couple, a system of forces. So see what I mean here. If this is, for example, this is a system of couple, like we have in pedaling a bicycle, is a couple. Pedaling a bicycle, turning of tap is a system of couple. Now, this is a force F, and this is another force. These two forces are equal and parallel, and they are also opposite. So there must be two opposite forces, and that two opposite forces must be equal, and also they must be parallel to each other. They can never meet. So then the distance from here to here is the distance between them. So that gives you a couple. So the system of force like this is called couple, like pedals of bicycle, turn of tap. Now, how can we determine the moment of a couple? The moment of a couple is called a torque. The moment of a couple is called a torque. A torque. So a torque is the what? The product of one of the forces of a couple and the perpendicular distance between them. So assuming that the distance between the two forces is d, so the torque or the moment of the couple is what? F times what? D, perpendicular distance. So one of the forces times the distance, because the forces are equal and parallel. So they counter each other. And the effect of a couple brings about what? Rotation. That's the effect of a couple. Thank you. Now let's look at center of gravity of a body. By center of gravity of a body, we mean the point on a body where the entire weight of the body appears to be concentrated. The center of gravity of a body is the point on the body where the entire weight of the body appears to be concentrated. Then if you talk about center of mass, it's the same thing. The point on a body where the mass appears to be concentrated, that's the center of mass or center of gravity. It is also the point on the body where the line of action of the weight passes through, irrespective of what? The standing. So that's the center of gravity of a body. For instance, for a uniform rod like this, the center of gravity is at the center. For a uniform meter rule like this, if this is a uniform meter rule of 100 centimeters, 0 to 100 centimeters, then it is believed that the center of gravity should be toward the center here. That is about 50 cm point for 100 cm uniform meter rule. So for a body that is triangular, you get the center of gravity. For a body that is circular, for a circular body, the center of gravity should be located toward the center. So that is it. That's center of gravity of a body. And it affects the stability of a body. A body with low center of gravity and a wide base is always stable, it balances. But a body with high center of gravity and a narrow base will be always unstable. The body cannot stay stable. Okay, let's continue. For instance, when you have a funnel or a coal resting on its base, it will be balanced because of low CG and wide base. When you invert a funnel, resting it with its vertex, like this body now is at equilibrium, it's balanced, it's stable. If I invert this, invert it to stand with this apex, it will be unstable. That is it. Now let's look at the principle of moment of a body. The principle of moment. The principle of moment states that when a body is in equilibrium, then the moment of forces about a point on that body, that the moment of clockwise forces about a point on that body is equal to the moment of anti-clockwise forces about the same point. So when a body is in a state of equilibrium, the moment of forces, see what it simply means here? When a body is in the state of equilibrium, for instance, if I to have this, and this is a pivot, and this is a meter rule, and it has to balance horizontally, it simply means that if I have a force here, here is distance 1, from here to here, where I have another force acting here, and here is distance 2. Here is my F2. So for this body to be at equilibrium, the sum of clockwise moment of forces about one point, this point, will be equal to the sum of anti-clockwise moment of the forces about the same point. We make the body to be in equilibrium. This is very important for the sake of practical analysis in equilibrium and moment of forces in physics. That is mechanics. Now let's look at this now. Simply implies this is, of course, you know how clock goes. The clock goes like this. So this is clockwise moment, and this should be anti-clockwise. This should be anti-clockwise moment. Sorry. So we know how the clock goes. So it goes like this. See how it goes. So in that case, we see that this one now, we have that this is the anti-clockwise moment, and they have what? The clockwise what? Moment. So the clock goes like this, but this one is going this way. This is anti-clockwise, this is clockwise. So for this body to be in equilibrium, the anti-clockwise moment will be equal to clockwise moment, which means F1 times D1 should be equal to F2 times D2 for this body to be in equilibrium. In other words, the algebraic sum of the moment of forces about this point will be equal to 0 in another language. Thank you. So with this explanation, it is important we take a typical question to explain more on this. That's a typical practical question, that calculation. So without wasting time, let's take this. Let's take this. So the question, look at this question. Let's look at this question on board. A meter rule, that example, to bring home our analysis of principle of moment of a force. A meter rule balances horizontally on a pivot at 40 cm mark when a mass of 40 grams was hung at the 20 cm mark. Then find the mass of the meter rule. So sometimes you might not have two masses to balance it left and right. Sometimes it will be demonstrated in such a way that the meter rule will be the balancing force on the other side, while you have a mass suspended on the other side. So that's what the question says. So solution, we have that we are given that this is the uniform meter rule. We have this at the uniform meter rule. Okay. So let's have this at the uniform meter rule. So this is the uniform meter rule. Then here is 0 cm. Here is 100 cm for uniform meter rule. It is called meter rule because it is 100 centimeter, which is 1 meter. Then we are told that 40 grams was suspended somewhere here. 40 gram mass was suspended at that it was suspended at 20 cm. At 20 cm. And the meter rule, this is the center of gravity. The center of gravity is here. The mass of the meter rule is acting here. That is the mass of the meter rule acting here. Then it was found that this is 50 cm, the center of gravity of the meter rule. Then it was, this is sketch. Now it was found that the body balances somewhere here. The pivot balances here at 40 cm. At 40 cm mark. So that is it. So this is the uniform meter rule. The weight supposed to act towards here, the mass, the center of gravity. Then it was observed by experiment, according to the question, that the pivot, when the mark was suspended here, the pivot was adjusted and the knife edge balances the meter rule horizontally at 40 cm mark on the meter rule, when the 40 gram was suspended at 20 cm from the 0 point. So we are asked to calculate the mass of the meter rule. Simple. From here to here, get the distance. 40 minus 20, have what? 20 cm. Not this 20 here, 40 minus, get the gap here. Then 50 minus 40, have 10 cm. So from here to here, the gap here is 10 cm. So taking moment, this is anti-clockwise moment. This is clockwise moment. So taking moment about this pivot, about pivot P, it will now be the F1 times D1 equals F2 times D2. In other words, in our case here, we have masses, which means M1 times D1 equals M2 times D2. So let this one be our M1, 40 times 20, then equals, we have 50 minus 40, 50 times 10. Times 10. So this is what we have. So, we have M times 10, M times 10. That is 40 times 20 this time equals to M times 10, the mass times 10, the mass of the meter rule. So this is mass of rule. This is the mass of the rule. So we have, this gives us 4 times 8, 800 equals 10M, such that M should be 800 over 10. So when you divide, you see that it is 80. So the mass of the rule is what? 80 gram. So the mass of the rule is 80 gram. So you can see how to calculate the moment of forces in questions like this. So thank you for your attention to this particular class. I believe with this class so far, you have understood the basic concepts and principles of equilibrium of forces in physics. For more of these solutions in physics and mathematics and the extra tutorials online, reach me through my contact number here. Don't forget to